Hi, my name is Nead-Work.
I'm Gabriel Kulp.
This is Ryan Kennedy.
And we implemented the wall of sheep for our network security project.
So starting in 2006, there was a presentation at DEF CON, sort of an ongoing display, digital signage that showed credentials that were sent in clear text over an open network. This is just to bring attention to the fact that you might not have the security that you think you do. This was done only sort of with consent. The networks at DEF CON that are open are just sort of assumed to be unsafe, so sort of on you. And it just demonstrated that clear text authentication is not a good idea. So unfortunately, clear text authentication is still around, and for people to be careful about it, they need to know that where it is and know that it's an issue. So our goal here was just to make that clear. The threat model here is you need to have open Wi-Fi so that packets that are sniffed can actually be read. So this includes open Wi-Fi with a captive portal, since that doesn't actually say that there's any encryption involved. And it would have to be in a public location where someone is actually able to physically be close enough to listen into packets. So airports and cafes are a perfect example of meeting both of those requirements. And then, of course, there needs to be someone on the network to actually capture the packets, which requires a wireless card that can operate in promiscuous mode, which means that it can read packets that are sent to it and packets that are sent to other devices.
Great. So this is a little bit of an example of sort of an example of what could happen in the wild. So right now we're talking about the HTTP protocol, but this is true of any of the protocols you would have seen on the first slides. So FTP, POP3, anything that doesn't use encryption. So if you are at the airport and you navigate to your bank's website, and your bank is like a small bank who hasn't upgraded to HTTPS, when you log in, you're sending in clear text, which means unencrypted, your username, password, and say whatever information that is about what you are doing on that website. So the guy sitting a few benches away from you at the airport will be able to see that information before it gets to the internet, allowing them to potentially change that, send that information as many times as they want. In the case of, say, a bank website, that would mean that they were able to take the money that you had intended to transfer from your savings to your checking and then change the account number, so you're transferring your savings into their account. So an example of prevention in this case is just upgrading to the protocol HTTPS. This puts encryption in between you and the internet. So before the information leaves your computer, your username, password, and everything else in the message will be encrypted, and it'll be sent to the internet. The bad actor who's sitting a few benches away from you, he can still capture all of this data, but it's encrypted, so he can't read it, he can't effectively change it, and he can't effectively use it.
So the application that we built has a few different components. First, we use the Zeek network security monitor tool to do the actual network analysis. And then we have a Flask backend server that's communicating with the front end written in JavaScript using Ajax. So let's talk a little bit about Zeek. So Zeek is a very powerful network security monitor designed for a distributed scenario. So in a typical environment, you would have Zeek deployed with taps in your outbound network pipes and other inbound and egress points in your network, so you can capture from all the important zones in your network. And then the packets are aggregated and sent to different workers for processing. Since if you are operating like a 40 gig pipe or 100 gig pipe, you being able to have one system that can process 100 gigabit per second of bandwidth is very, very unlikely. So Zeek is designed to be distributed to multiple workers and has a manager node that helps to take the work and make sure things are done between the workers and that the communications are kind of coalesced. So if one packet in a stream goes to one worker, another packet goes to another worker, the manager is able to identify, oh, these are the same stream, and connect those so that your logs have full information and can be enriched with any data that comes across the network, which is super helpful. And so all you have to do as the end user is communicate with the manager node or whatever front end for logging or visibility that ingests these logs. Zeek outputs just text logs either in its own tab separated value format or in JSON, and then it can be ingested into something like Elasticstack or into Splunk. So let's talk a little bit about the Bro architecture. Zeek used to be called Bro. They renamed it to Zeek last year. But it's now built so that it has packets coming in. You have your inbound tap. Packets are coming into a network interface. And then inside of Zeek, it has this large engine that processes the packet, tracks different sessions, different connections, and rebuilds all these streams into a really easy to use fashion. And then you, as the analyst, can write scripts that run in script land that can interact with the protocols and different events and handlers that they expose. So that your scripts can be tested easily, they can be written quickly, and you can fail fast and learn really quickly what's working and how to write good scripts that are event-driven to process this data. But if you wanted to write your own protocol or write some custom functionality that isn't currently present in scriptland, you would write a BIF file, which is a built-in function. So you can define new events, different types of things that you can then trigger from scriptland to keep your scripts clean and easy to read, and then do all the hard to compute things in BIF, which is a wrapper on top of C++. So most of the things that you can do in C++, you can write in a BIF file. So like I mentioned, the scripting engine provides a really powerful event-driven way to interact with the data. So this sample event from our code is the HTTP end entity. So this gets called by the Zeek event engine when it's finished processing HTTP request. So all the data has been reassembled, it's built the full stream, and then we have our connection object and the is_orig value. So the is_orig just allows you to determine, was this request coming from client to server or from server to client. So in this case, the couple of things that we're processing after request is fully built is for basic authentication and for post-based form submissions. So Zeek has some built-in support already to parse out basic authentication. So once we've enabled that, we're able to parse the fields for username and password and then log the username and password fields. Otherwise, if there's a post body, we call this other function that will take the post body, and if it finds credentials in the post body, then it will save the post body for us.
Okay, so a couple defenses against attacks like these are using secure WAP2 Wi-Fi. So this is the kind of Wi-Fi that you would find in your house, and what this prevents is attacks such as a guy sitting across the street in a van listening on your Wi-Fi, because if you're password protected, it's pretty unlikely that he's going to be able to connect and then decrypt the packets that you're sending. And so that essentially means that on your home network, you have a certain level of trust and you have a certain level of ability to send packets, because the only bad actors are if your kid's a hacker. Unfortunately, though, this doesn't prevent against like networks that give out their Wi-Fi password. So if you're in, again, like a public place and there's secure Wi-Fi, but the secure Wi-Fi password is written on the countertop, then this isn't going to really prevent much from a person, say, inside the building. The other thing you can do is you can check for HTTPS/TLS. So most web pages, most web browsers will have some sort of a lock or a color in the URL bar. So when you type the website name, that'll tell you if you're working on a secure network or an insecure network. Insecure website. Unfortunately, this kind of thing isn't necessarily communicated in, say, email clients like the protocol POP3. So you're going to need to manually go ahead and make sure that that's turned on. And that's kind of one of the unfortunate things about preventing attacks like this, is it's not very clear to the user if they're using a secure protocol or an insecure protocol in things that aren't just websites. So again, you want to only use credentials on trusted networks. That's kind of the difference between your home network and the coffee shop network that has a password. And in general, you would want to use multi-factor authentication, but that'll only kind of work. So if your authentication is static and you end up sending, say, a second password, sending a second password won't prevent somebody from grabbing that and using both of them. However, using something like TOTP, where the secret is not sent, will be fine, because unless the attacker uses that within the amount of time that it's generated.
Another MFA solution that you could use is Duo, where there's no second request over the network. The request comes through a second channel, and then validated off your phone, which is another possible defense. Not really, but it's a workaround. So now let's run through a demo of the platform. So first, this is our user interface. So as credentials are sniffed off the network, they will show up here thanks to the AJAX request happening between the client and the server. And here is a little dummy page where I have a few different forms built that we can use to see different types of requests and see what we're able to parse. So first, let's make this post request. So we make our request, and then we see that we see the server, the username, a censored version of the password, and where it was found. So this was found in the post parameters of that request. Now let's make a GET request. It's not very common to see login forms using the GET method, but it's not impossible for this to occur, so we're able to sniff these as well. So we submit that form, and we see that we have this GET user with a new password off of the GET parameters. Another type of authentication that we support is basic authentication, which is a relatively antiquated part of the protocol, but this pops up a prompt to enter your credentials, and then we see that the basic auth has been parsed and has got our username and password for that field as well. Now let's talk a little bit about the scripts that allow this to work in Zeek. So a script in Zeek, when you're defining a new log type, you have to define the different fields that you have in the log. You can provide some options for someone that uses the script in the future. So we designed the script to be used by another person in the future so that they can configure things like password redaction, how much of a post body to parse, because there is the chance that someone can make a very large post request with a lot of data, maybe it's a file upload, and we don't want to accidentally cause undue burden to the server, because it's unlikely that past the first 200 bytes of a request that we're going to find credentials. So after 200 bytes, we stop looking at a post body in order to save resources on the server. The consumer of the script can also configure the different username and password parameters to look for. So in this case, we're looking for either a username parameter or a user parameter to find a username, and password and pass for password as well. And we also keep track of which credentials have been found. And we do this on a uniqueness base of username plus password plus where it was found. That way, if we are logging duplicate credentials, it won't overflow the log and create unnecessary entries in our final application. There's a few different ways that we're parsing these requests. First, there's the first request, which is where we can handle this URI string. So get parameters are present in the URI, and in Zeek, we're able to find this when we look at the script's HTTP request. Because once Zeek initially parses the request and generates this event, we know we have some of the data, but it might not have all of the body yet. So we're only able to look at the URIs at this point. Then we can trigger a stream event using the file over new connection event. And this is a stream event. So this can be triggered multiple times throughout a connection's lifecycle whenever there's more data present for this request. So at this point, we are appending data into the body so that it can be processed by the end entity handler. In case this gets called multiple times, we don't want to overwrite any data we've already captured. So once HTTP connection has the end of its life cycle, we first check for basic authentication, like I talked about on the earlier slide. And if we find this, then we're able to log that data. And we're also checking for a post body from the handle post bodies function. And if that's found, then we will attempt to parse credentials from it as well and save them to disk. This is the end of our presentation. Thank you. Have a good day.